Thumbs up. So part 1 is done. That's my expression. I mean, I can find out the number if I like, but it's not going to help me with part 2. Hence or otherwise, determine how many years, Mr. Wu, how much I have to invest before I get to that number. Okay? Now, if all I was doing was investing $1,000 and there was no interest, how long would it take?
30.
It would take exactly 30 years because $1,000, $2,000, $3,000, $4,000, but that's not what's happening. Interest is being applied. So whatever number, whatever answer I get down the end here, I'm going to do a sense check. It had better be under 30. Otherwise, this is the worst super account of all time. Okay? How am I going to get toward an answer? I see a pattern, right? I can say, if this is what it is after 3 years, then after n years, it ought to be, and I'm going to try and fill in the pattern, right? Well, have a look. There's so much structure here. Surely you can recognize what's going on, right? If you have a color there, another color. I've got A1, I've got A2, I've got A3. Do you notice they all start the same way with this guy? You see that? I suppose I should say they end the same way. Okay, that's always the last term. Okay? And then what happens is it just sort of climbs up in power like this. You see that? Until such point as I get to what number? When do I end? When I get to the nth term, which is the third one in this case, the second one in this case, and so on. Okay? So therefore, the very first term I'm going to write here will be $1,000. And how many lots of interest have been applied to it? N times, right? Stop calling me. N lots of interest. Because after all, this was the very first bit of money that you put in there, and it's been in there for n years. You okay with that? What's the next term? It's going to be one less. You see it climbs down, 2, 1, etc. So I'll write, whoops, I didn't need that. I'll write the next one. Plus dot, 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 dot. Okay. Now, where's it going to end? It's going to end, it always ends on this spot, right? That's always the last one. Okay, now just for the sake of it, I'm going to put a 1 here. I know that seems a bit redundant, but you'll see why in a second. Think back when we were doing some of our earlier questions, right? At this point, I'm now ready to say, I recognize a series here. I can actually label it and say it's a particular kind of series. What particular kind of series is it? This is a GP. So I'm going to say the words. This is a GP. What 3 features define a GP? Well, there's a starting term, there's a common ratio, and then there's how many terms there are, right? So what is A? What's the first term? Now, I've written it from big to small, right? But I can write it backwards if I want to, and that's probably easier for me because this is an easier number to write, yeah? So I'm going to say A equals this guy here. Is that right? I could say R equals 1.05. That's the common ratio every single time. How many terms are there? Now, if you recall one of our earlier examples, we looked at like a concrete number here, right? And you'd say something like, oh, there are 7 terms or 8 terms. And I said to you before, I don't like writing n equals 7 or n equals 8. Because when you get to a question like this, you would say something like n equals n, which means nothing, right? But there are really n terms in here. So that's why I'm going to write n terms. Be careful. Sometimes there are n plus 1 terms. Sometimes there are n minus 1 terms. How do I know without a shadow of a doubt that there are exactly n terms and not one more and one less? How would you reason it through? So it ends here, right? If I would count up to that n, right? It goes 1, 2, 3, 4, 5, 6, all the way up until n, right? Suppose my last term was 0, like that. How many terms would there be now? There's an extra one. You see that? I would count 1, 2, 3, 4, 5, 6 all the way up to n, and then there's an extra one, a plus 1. So you have to look out for these things. We often have off by 1 errors, and they come up in spots like this. Okay. Now, just before we leave off this, This is not the only GP you could have formed, right? Do you see all the way through this term, every single term has a couple of common factors? Do you notice that? What are the common factors that appear every single time? 1,000 and 1.05. So if I wanted, I could have factored all of that out, and then I would have a different GP, okay? It's going to come up with the same answer, but just so that you know, you can form different GPs with the same set of terms. Is that okay? All right. Why did I go to the effort of pointing out that it's a GP? It's so that I don't have to write every single term. It's so that I can use a formula. What's the formula I can use for the sum of a GP? There are two formulas, right? Do you remember what the two are? Yeah, that's right. I'll give you a clue. They both start with an A and they both are fractions. Okay, so there's this one, and then what goes up here? 1 minus r to the n. If you're thinking about it without the 1 minus r to the n, what is that? That's a special version of this. What is this guy? It's the limiting sum. That's right. So you know how some series converge on a particular value? That's when you can use this. This does not. It just gets bigger and bigger forever. So this is kind of not much use to us. Okay. This is not the only way you can write the sum of a GP. What's the other form? It still starts with an A, and it's still a fraction. See these two? I can flip them around, right? Now, they're both the same formula. They're literally both the same formula. But which one would you prefer to use in this case? I think I prefer this one. What makes me tend towards the second one rather than the first? Yeah, see that R there? On the bottom there, it's going to give me 1.05 minus 1. It'll be a positive number. If I stuck it in this one, it'd give me a negative. That'd give me a negative 2, but I just don't want to have negatives. I just get confused, okay? Right, let's pop it into this formula then. Are you ready? Here we go. A, 1,000 times 1.05. There's A. In the brackets, 1.05. Sorry, did I write the right one? Yes, I did. To the power of, have a look at the formula. It's just n, right? Because that's how many terms there are. That's why I bothered to write that down, so I know what goes there. Okay? Take away 1, and then the bottom. How's your brain doing? You have turned this wordy problem into a simple GP. Okay? This is a n.